Everyone, it's May the 23rd. All right. I already see the problem we have today. Number 32, longest valid parentheses. Hard problem. So I was telling myself, no fear. Let's just go into it. Maybe we can do it this time. I mean, I have done this at least 2 times, I think. That's what I believe. Oh, let's see. Given a string containing just the characters left and right parentheses, find the length of the longest valid parentheses substring. Alright, so what I want to do is to find the substring that contains the longest valid. And because we are in the week, or at least the current stage of DP, we're definitely going to attack this with DP. Okay? So we have a bunch of strings, right? So we write it out. And we want to see what is the longest valid substring. So it has to start somewhere. It has to end somewhere. So the problem is, if we think about DP, is ending at this position. What is the longest substring we can find that's valid, right? That's what we want to find. So we take the first one. It's definitely not going to be. So we'll take the second one. How do you determine what is the longest valid? So if it's the longest, if it's a valid substring ending at me, that means the previous one we defined a valid, right? It has to be valid in the previous one. If the previous one is not valid, the current one will never be valid, because the valid means inside it has to be valid. It has to be a valid, and you add something. So that's one, right? That's one. But here is the catch. Here is the catch. If you have something, right, and you can look to your left if you are a right parentheses, and your left is a left parentheses, and that is a valid, right? And then your problem is to look to that one. What's the longest? What's the longest ending at that one? So it has to be a right parentheses. Right? It has to be a right parentheses. So the job is, if I am a left parentheses, then it's a 0, right? It's not going to be a valid thing, right? It's not going to be a valid thing. But if I'm a right parentheses, I need to search, right, for the left parentheses, and that means the things inside has to be valid as well. Well, 3 times 10 to the 4th, so things inside has to be valid. So for each one, if I find the longest that's valid here, that means there has to be it's absolute longest. But it could be that we find some. So what do we need? We need to know if I'm a right parentheses and the one in front of me is a left parentheses, then that's a valid one. Already, we already find a valid one. And then the problem becomes the longest of the previous one, right? And that and a +2. That's that. And we cannot ignore. So basically we're trying to find all the left parentheses that can match to my current right parentheses. We want to find all of them, and then define the longest. Go this, and then try to find which one's the longest. So for each right parentheses, if we can have a list of left parentheses, a list of the length. So not just a one length, but a list of lengths. I have a length of this, length of this, length. So for each of the lengths, now we have this. Try to find the maximum on the in front. Okay. So this one will be O n times We're looking at O1 squared if in this case, but we can give it a shot and see how it works. But if we have that, so we have to go through every single one. So in this position, I have a list of lengths, right? A list of lengths, size, the length, right? A list of lengths, and then for each length, I can find if it's not good, I'll go for the next one, and not good, I'll go for the next one, and do we find something good, then we can update, and that's how we get. So for this one, it will be 0 if no length. So it will be just this minus, well, if the length is, well, for 1, it has to be a, either 2, 4, it has to be an even number, right? So if we look in this, and then it should be empty. That's an empty case. It's an empty array. Go here is empty because that's a left parentheses, and we go here. All right. So what do is we go left. Right, and the left is a. If the left, no, that's 1. So we'll say the length is 2. All right. And then keep going. No, we have to. Oof, are we having to go through every single one? Hold on. I need to find something that's valid, and then I can add a parentheses. So I should only look for the one to my left. That's it. That's the only thing. I look for the one to my left. If the one to my left is a left parentheses, then we're good to go. Then we look there. If the one to my left is not a left parentheses, it's a right parentheses, and we just need to find. Because if there's nothing, if the right parentheses cannot form a good one, then there's no chance for me, right? If my left is a right parentheses, it has to form. It has to have something, right? Otherwise, like, there's nothing I can do. I cannot form, right? And think about it. Is that right? Yeah. Because the only way to allow me, because I'm a right parenthesis, I need to find a accompanying left parentheses. So either there's nothing in it, or there's something in it, and the something in it has to be a well-formed. So we only need to check one, and that one will check every single one of them. So we're going to go to check every single one of them, right? Or check and this, and then we check the maximum length on that. And then we check this, or check the maximum length on that, we check this, and everything we check. And every time we check, we are forming something, right? Because it has to, we have to do it this way. And if it's left, then we go for the to the left. And the left is an empty, then that's an empty, then we don't have anything. And if it's a right, then we have the entire of that, right? The entirety of that, which means just the longest of that. And we just say for this we have the longest. And if it's a right parentheses, then find the longest. And if it's not, well, it could be a could be a smaller. Like if this, we have a smaller one. Right, for this, let's say I have this. Wait, hold on. For me, can I form different valid substrings? Can a right parentheses form different valid substrings? A valid substring is me, it has to be associated with the left parentheses, right? And if it's valid, and everything inside has to be valid, right? Which means if I say I have multiple, which means this is valid, and then this is valid, then we're violating, because if this is already valid, so no one can spare, which means that's only one. Right? There's only one. So for each right parentheses, there is only, oh, hold on. There is a slight difference. There is the longest substring that's valid and the substring that can make this right parentheses valid. There is no one such a thing to make this right parentheses valid, right? That's that. So I have the longest that make me valid, but I can also have the longest substring that is entire thing is valid. So what I can do is I can do that, right? So I am in the right parentheses. I look to my left, it's a left parentheses, so I just look again to my left. And that's the end of the story. Now if I'm a right parentheses, and my left is a right parentheses. So I know the right parentheses make it valid, right? Then to make it further valid, I need to look at that. And that has to be a left parentheses, right? It has to be a left parentheses. If it's not a left parentheses, then we know this is a valid, and then we cannot find another. If it's not left, if it's a right, there's no way we can find one. I think I have some idea. Let's try it. I'm also trying to, learn more how what actually is pronounced VI, how VI works, or better yet, how Vim works. I've been trying, right? But the goal is to not use. Goal is to not use mouse at all. All right, here. Anyway, so here is what we want. What we want is at each, because the left parenthesis is 0, right? So at each right parenthesis, we need to know the one that can match it, right? We don't know one that can match it. and then we need to know the longest. So it's basically two values, right? One is the longest, the one we want, and the other thing is the valid, right? The one that makes you valid. Okay. Okay, so you can do a DP. DP. Well, the first one is always going to be if it's the right, it's the left, it's always going to be 0, right? So we say the longest, right? The longest is going to be 0, and the one that can make you. Ooh, do we record the length or do we record the index? To me, I think the index is easier to reason with, right? The index is easier to reason with. Oh, hold on. If it's index, what type of index do you want to put in there? Right? It's not that. It should be the length. Okay, so length is 0. That's the starting point. We already know. So we say for I in range 1 to n. Okay, so for each one coming out, say if si is equal to a left parentheses, then dp.append. There's no question about it. It's going to be 0, 0, because a left parentheses cannot form anything. But else, if it's a right parentheses, then we have different scenarios. So the first scenario is if, say, I can actually just put it here, elif si minus 1. So I am a right parentheses. If I minus 1 is equal to a left parentheses, then I already find my pair, right? Then we say dp.append is going to be, the length is 2, because adding me is length is 2, right? So when length is 2, oh, that's the second one. We want the first one to be the total length, right? When the first one to be total length, so this is the second length is 2. And the first length is going to be, well, definitely 2 plus dp, right? I minus 1 and I minus 1, right? I minus 1, I minus 1, minus 1. Now that also depends. Hold on, I need to do something very important. Well, tomorrow I'll come and go. My thing is, where is Jimbo going to hide? That would be the best place to hide. They call you and stuff, you just put your money in the carrier. Zip it up, we don't have to worry about it again. Hopefully they came after we feed him. Should we feed him? I hope I put him in the bathroom. Let it off in the bathroom. don't have a bathroom box, and I don't think they will unbox a bathroom box for us.
I know, but they can put it inside the bathroom.
Now do it. I think they will put all the box on the outside and then just unbox the bin.
Well, yes, but they will put it in the correct location.
Yeah, I'll tell them what kind of the bathroom. And do everything else.
Okay, I think Jumbo will feel more safe in the carrier.
Yeah, let's put the Jumbo in the carrier.
What if they open the bathroom by accident?
Yeah, let's put Jumbo in the carrier. More discussion. Discussion ends. That's the best solution ever. Alright, back at it. So what I find right now is we might have an issue here. The issue is what if we don't have -2? So we see, right? We have to see here. If this one, and we say, if I -1, actually let's do it inside. Right, what we want to do is -2, right? Because I -1 is the left parentheses. Then we do I -1 -2, and that we have to go with the 0, the longest, right? 0 is the longest, so it'll be 2 current plus this one, the longest, and that will be the current longest. And this will be if I -2 is larger or equal to 0, else just 0, right? Else just 0. So this is $pen, right? Else, which means I -1 is not a left parenthesis, it's a right parenthesis, right? So in front of you is a right parenthesis. So if that's the case, if that's a right parenthesis, then you need to find that. Then we just say if we need to know it's matching, right? And how do we know? So for this one, if it's 0, right? If it's 0, which means nothing matches that, then for you, is going to be 0. And we say if dp I -1, 1 is equal to 0, then dp.append for you is going to be 0 as well, unfortunately, because the one in front of you has nothing to match. Otherwise, it's not a 0. So the one in front of you has a match. And then what we're going to do is to look for that thing, right? To look for that thing. So we're going to say J is going to be dp I -1, 1. That's the length, right? And it's going to be I minus this length, right? And then plus 1. Because we're looking at, it's actually I -1, right? I -1 is the index, and we go 1, 2, right? We minus the length, right? This one minus the length, then plus 1. That's the thing, and then we can simplify that. Just do this. So when you say J is equal to this, so this J is. Hold on, I need to do another important thing. back at it. So where we are. So we have this j. This j is the index of the left parentheses, right? But what we don't want, we want the one right in front of it. So that's what we're going to check. And we say if j is larger or equal to 0, right? If j is larger or equal to 0, and let's say sj is a left parentheses, and then we have found a match, right? We have found a match for the current one. We found it, and now that we have found it, it's actually the same situation as this, right? It's just going to be j minus 1. These two situations are exactly the same. Exactly the same. So we're going to do the same thing. Exactly the same thing. Well, not exactly the same, but it's going to be this is going to be j, right? That's the total count. That's not j. The count. No, hold on. So j is this, right? So we're gonna do what we're gonna do. So it's going to be 2, right? Plus dp I minus 1, right? That's the length. And then this is going to be 2 plus dp I minus 1, that's the length, plus dp j minus 1 is 0. If j minus 1 is larger or equal to 0, else 0. Yeah, let's put a parentheses just to make sure everything is correct. Well, actually, the parentheses is here. No, hold on. Parentheses is here. If this, else 0. That's the parentheses. Here's the same thing. This is the parentheses. Right, so that's if j is larger or equal to 0 or sj is a left parentheses. Now, if j is smaller than 0, okay? If j is smaller than 0, well, if j is smaller than 0, what does that mean? Well, that means there's nothing for me. So I just say if j is smaller than 0, then there's nothing for me. Then dp dot append, it's going to be 0, 0 because nothing, right? Because the previous is nothing I can match, so like this. So I'm going to say elif. We have a j and it's a left parentheses. And we do that. And of course we have another else. So this is the left parentheses is the left one. Sj is also a right parentheses. And that's the same situation, right? Then it's a 0. So if j this, or so j is larger than, but sj is equal to a right parentheses, then we do this. Else is larger equal to 0 and it's not. So the else is going to be this, right? And then that's how we do. And we're trying to see, and then we need a res. Come on, a maximum. So actually, let's do the max at the end. Basically, we just say return the maximum of for in DP, right? We want a maximum D. All right, let's try this one. See how it goes. So we have this, right? We shall return 2. And this shall return 4. And this shall return 0. Okay, looks promising. Let's give this a shot. Let's see. Wrong answer. Expected 6. I only got 4. Okay, that's fine. That's fine. Let's take a look. Should be 6. All right. No biggie. No biggie. We just see what DP looks like. So 0 0 0 0 2 2 and this one is 0 0. This one is 4 2 and this, right, and in front is a right parentheses, so it's here. So J will equal to I, so 0 1 2 3 4 5 5 minus 1 is here. Oh, you're right. I see. It could be both. Oh, now we have an issue. See the problem? Now we have all of them. We have the parentheses, we have this, and we don't know which one to match. But do we know which one to match? Well, we know is this one, definitely we can match, right? We're gonna try. And then we're gonna have another one. But if this one, if we have another thing that's matching, right? We have more things that's matching. So think about this, right? Think about this. We have something that's matching, right? And then we also say we want the longest, and they are all matching, right? And they're all matching. So if they're all matching, and then you only use the smallest matching actually right now, then it's not going to work because you're not going to find anything. So you have to use the longest matching, which means we might get away with just the longest matching, right? So basically we say this one, we'll just do 0. This, and if this is right, then we're gonna do 2, and then oh, actually we're not gonna do 2. We're gonna say 2 plus 2 plus this if it's larger than 0, else we're just gonna append this value, right? Because this we have 2, and we have 2 plus dvi minus 2 minus 1 minus 2, right? Because we think we should always go for the longest. Okay, no, and then we say if this is a, so now this is a right parentheses. Now if it's a right parentheses, we just find the longest, right? We're gonna find the longest. So we say if it is a 0, right? If it is a 0, then we say there's nothing we can do. So I append 0 as well. But if it's not a 0, then j shall equal to this. and then we say if j is smaller than 0, or this is the right parentheses. So basically we say this is the longest, but outside of it is the right parentheses. And then we cannot match. Alright, we cannot match you. In this case, we're going to do 0. But if we can match you, then we're going to do this match you plus this, right? And then plus j minus 1 if this else is 0. And that's that. We have just max dp. Yep. Okay, so we have this. If the front one is, then we do this. If the front one is the right parentheses, then we see if it has, if it doesn't have anything, then we go 0. But in fact, if you think about it, if this is 0, right, then this is j equals I minus 1, right, j equals I minus 1, and if j smaller than is equal to, so we don't need this situation, right, we're directly using this, because this is 0, then j, the matching one, just play by itself, and we say it cannot be like this, and then we just add 0, else we add this. Alright, try this. Nice, we got it. So it's not that complicated. I think the difficulty is with identifying, right? Identifying the where the DP is. Yeah, it's been a very long time. Look at this, 7 a.m. 10. I think I checked the results, so maybe I figured something out. It was ridiculously long. And then we did again. Oh, look at this. I started at 7. I took a break, and I did again at 5. No, I think that was during the internship, right? No, that's not internship. I think internship is 2019. That was before. And remember, those were the days I also tried to do like one LeetCode and one Project Goila. And then wow, all the way to 7 o'clock, the entire day. And then we did again April, 2 wrong answers, and I got it. Did I get it myself? Curious. Let's take a look. And then this is the last one, so take a look. And this is the current. So 32. A lot of checks. Not sure if I like it. Yeah, let's make some changes. Times n, right? And then if it times n, we can just say if it's equal to this, and we say if this is this, then dpi equal to this. Else j equal to this, then if j is larger than 0, and this is the left parentheses, dpi equal to this. feel these two can be combined. Let me see, how can we combine it? We can say if this one equals to this, we just want j, right? J shall be I minus 1, right? If j equals I minus 1, yeah, this one basically is 0, right? Because dp I minus 1 is 0, because it's 0. So j, which means don't need this, j will equal to this. And then we say if j, then this will be 0, which is fine. Max is the empty. Max is an empty. Oh, we say if dp, if not n, turn 0. Right? J, well, this is the index of the matching. Left parenthesis. Potential. Yeah. Let's see, with this, would it be, should be fast. So this is not a hard problem if one figures out how the DP works here. So for each this, it cannot match anything to the left. For each right, we need to find where it's matching this is. To do so, we check, right? Now it's the index. Let dpi be the longest valid paren ending at si. Then the index for a potential match of the current right parenthesis must be I minus dp I minus 1 minus 1. Right. You say if si minus 1 is equal to this, then dp I minus 1 must equal to 0, which makes the matching paren for this si minus 1. Otherwise, if si minus 1 is equal to a right parenthesis, then I minus dp I minus 1 minus 1 is the dp this is the paren that matches si minus 1 and minus dp I minus 1 plus 1 minus 1 is the paren in front of that matching paren, which is also the paren that we want to match. Also the paren that we want to match the current this. I'm not sure if it makes sense, but if you read into it, it does make sense. If this paren is a left, then we have a match for the current, right? Current right, and the longest valid paren is dp. J equals this. We say dpj minus 1 plus 2 plus dpi minus 1. Right. Otherwise, there is no match. There's no valid paren ending at si. Let's read again. Matching paren for this becomes this. Yeah, otherwise, if this is the right parameter, then this is the paren that matches this, correct? And then j equals this. Basically, just this one minus 1 is the paren in front of the matching paren, which is also the paren that we want to match the current right parenthesis. Yes. Actually, I shouldn't say this. We want to match si. That's what we want to match. And we have a match for si. Right. And the longest is this. Otherwise, there is no valid parameter matching. Yes. So now we can submit this solution, which I believe shall be faster. Hopefully. 77, slightly. Is on, because we go through this one only once. Okay, let's check the solutions we have in the past. Oh, a stack. Huh. Interesting. A stack solution. I didn't think of stack at all. I think it's a better stack. Okay, let's see. This is what I have. Yeah, it's the same number of test cases. Okay. Setup delimiter. Delimiter. Every right parentheses unmatched right parentheses. That's true. That's true. So what do? We say this, right? If the left, we push. Else, it's a right. Because either this match, or it is a new parameter. We only need to have one delimiter in stack. Yeah, so we the left will also push in, and then now the right comes in. Now we always pop, okay? So once we pop, we say if stack, then become I is the current, minus stack minus 1, which is the current top of the stack. Now the top of the stack is the delimiter. It's where the streak ends, right? Because we keep going back, and then we will find either a left parenthesis that will break, or the right parenthesis that's unmatched will be breaking point. So on the top of a stack, always the most recent breaking point. So now I can come in, right? I come in and I pop it, and if I pop it, we check the top of the stack, and then if the top of the stack determines the length of the current, yes, and that will get that. Else, which means if we pop it out, then the right parenthesis is by itself, right? Yeah, if it matches the right parenthesis in, will always match. And if it's something that we do not match, we push left parenthesis in, and as long as there are right parentheses, then we'll always match. The unmatching situation happens is if we have more right parentheses than left parentheses, that's when we have unmatch. And that's when we pop it, there's nothing in it. So right, so if we pop it, then there's nothing in it. So there's no left parenthesis to match the current right, so we have to push it in. Ooh, this is interesting solution. Yes, I actually have the solutions. Yeah, brute force is not gonna work. DP. Huh, maybe I use this DP. It could be. Stack. Yeah, stack is the easiest solution. Without extra space. Okay. What if we go right, left, left? right, right, left, left. So anytime if right becomes greater than left, then we'll reset left and right, because if right is larger than left, that is not going to happen. Same thing, we go right to left. Whenever, actually if left is more than right, yeah. Okay, so we count how many right and how many left. At any time, if right is more than left, that means it's a right, right, left, left situation, right? So we just reset both to 0. And we keep going. So we make sure the left is always larger than right. And whenever they are equal, then we definitely will have found a match. Okay. And then go the other way. I'd like to have the stack solution. I think that's why I choose the stack solution. Like, I'm not caring about the left and right thing. Okay, so this is the stack. The stack solution. The key idea is that as long as there are, we always push left parentheses onto the stack. Then when this shows up and there are this right in the stack, we always have a matching pair. Now, bad thing also, unmatch happens when the stack is empty, but we have a right parenthesis at hand. In that case, we simply push that paren into the stack. Right? We push the paren into the stack. To serve as a delimiter. That's what I call it, a delimiter. But a better way, we want to push it in, because we want to push it in to indicate that there is something inside that's not good. It serves as a sentinel to indicate the next possible mismatch. Okay, so this is our stack. I say this. I say for I P in S, enumerate S. P is left paren, stack.append, I, else, stack.pop. Now it's either a left paren, either this or this gets popped. Doesn't matter. If it's this, we have a match. If it's this, stack will become empty because it can only be at the first position. Right, so we pop. I say if stack, okay, res equals the match, res. Now the current I minus stack minus 1. Okay. Of course, we need to have a 0. Else stack.append I. So mismatch, unmatched, right parentheses, return res. Ooh. Oh, also, we'll always need to put something in there. Yeah. Alright, so this is what? So this is the O1 space solution. Intuition is that we go from left to right and keep count of the number of left paren and right paren. Whenever the count of left paren is smaller than right paren, we have a problem. So we reset the count immediately. Otherwise, whenever the two counts are equal, we have found a valid string of paren. We keep track of the largest So we keep track of the largest length. And we do the same thing, going from right to left. The only difference now is that we reset count when the number of right is larger than the number left. So this is on time and o1 space. Okay. So I'm going to say I'll count the right count, 0, 0. Okay. And then rest equals 0. Say for p enumerate s, not enumerate s, just go s. P is equal to paren, and go up, go to the end. This left one else equals 1, and else right count equals 1. So if left count is smaller than right count, left count equals right count equals 0. Else out of left count is equal to right count. Res equals maximum and res. ls equals c. Right, and then say for p in reversed s, if p is equal to this, else equals 1. Oh, we need to reset. Yeah, I can reset here as well. So this is else c plus equal 1. If RC is larger than LC, they're the same. For the first one. Ah. That goes wrong. This one large, and there we go. Okay. All right. I think that's it. That's it for today. 3 solutions. All right. How be it? Good. That's a good problem. Very good problem. We spent 1 hour, 12 minutes. Good time. And I'll see you guys tomorrow. Adios.